Sathyabama Institute of Science and Technology.
Hi, I'm Shamili, Assistant Professor, Department of IT at Sathyabama Institute of Science and Technology, Chennai. Now we are going to see the topic public blockchain, Ethereum. So basically blockchain, it's a decentralized distributed ledger where all the data that are stored in a ledger format, which means it is replicated to all the other peers in the network that is stored as a ledger. And then key features, which is immutable, transparent, secured and decentralized. Immutable, which means no other data can be edited, modified or replaced. And then transparent, which means it is visible to all the other peers. And then secured, it is secured under SHA-256 algorithm. And then decentralized, which is distributed. And then next one, the types of blockchain, which is first one is public, second private and then consortium, where public comes under the Bitcoin and Ethereum, and private comes under Hyperledger, and consortium comes under banking consortium, where consortium means it's a hybrid one, which means both public and private. Now public blockchain, where public blockchain is a distributed ledger technology which is open to anyone in the network, where it allows the participants, which means the peers, to access, view and contribute to the record, which means none of the records can be deleted. If someone tries to modify it, it is replicated to all the other peers in the network. Then they operate on a open source framework. Here framework, which means we are using Ethereum for public blockchain. It also uses the cryptographic principles, where cryptography means encrypting the data and decrypting the data, which means, as I already mentioned, for public blockchain we are using the SHA-256 algorithm. And then it also promotes innovation, transparency and digital economy. Innovation, which comes under the DApps, which means different types of decentralized applications. Transparency, which means it is visible to all the peers. And then digital economy, we came across many of the digital cryptocurrencies. Example, Bitcoin, Solano, etc. And then the key characteristics, which means first one is decentralized, transparency, immutability and then consensus mechanism, where decentralized, which means all the peers in the network are distributed all among the world. Then transparency, if suppose I am doing a transaction, that transaction is visible to everyone in the network. Then immutable, immutable means we can't delete the data. Next one is consensus mechanism, where consensus comes under the agreement basis. How public blockchain works? First one, transaction creation, second one, broadcasting and then validation, block creation and then adding the block to the blockchain, and then the incentives. First, transaction creation. Both the users, which means the sender and the receiver, are making a contract basis transaction. If suppose I am transacting particular amount to the sender, which means the receiver and me will go for a contract basis. Like if you give me the amount, I will do the contract basis. Then broadcast, if suppose the transaction has been done, that will be stored in a block. That block will go and settle into the mining pool area, where mining pool area is the area where every transactions are settled down. Then validation, where validation comes under mining process. The miners who undergoes the mining process is called the validation. There comes the consensus algorithms, which means proof of work, proof of stake, proof of authority and some other proof of works. Then block creation. After the validation of the blocks are created and added to the blockchain network. If example, I am doing a transaction, that block is verified by the miner, that block comes under the blockchain network. The miner who verified my block will get an incentive that I am giving. If suppose a miner is verified a transaction of mine, I have declared that if you verify my block, that I will give you 10 bitcoins, like that. Then Ethereum, where Ethereum is the open source framework for using public blockchain. Vitalik Buterin is the father of Ethereum blockchain. So Vitalik Buterin, at the age of 19, he founded Ethereum and also he wrote a paper called Ethereum White Paper. And Ethereum framework launched in 2015, where Vitalik Buterin donated almost 50 trillion SHIB tokens, which worth $1.2 billion for the COVID relief to India through entrepreneur Sandeep Naiwal. And then Ethereum versus Bitcoin, where Bitcoin is a digital currency, but Ethereum is a cryptocurrency, which means Bitcoin also a cryptocurrency, where Ethereum is a ETH cryptocurrency. For Ethereum users, Ethereum is a platform to use decentralized applications, where we can customize our decentralized applications. And then this is the overall architecture for Ethereum, where Solidity code, Ethereum compiler, and then Ethereum virtual machine, where Solidity is the language which are predefined and that are deployed coming under the contract. Everything comes under the virtual machine, where the blocks are added. Ethereum virtual machine, where Ethereum virtual machine is a runtime environment for executing the smart contracts, where smart contract comes under the agreement basis of peers who undergoes the transaction process. Solidity, as I already mentioned, Solidity is the primary language that are used to write the smart contracts on the Ethereum blockchain. Next is smart contracts. In particular, smart contracts is a self-executing contract basis, which means the Solidity code that I am defining what type of process we are defining, which means if I do a transaction between the user, which means me and the another peer, that we have gone for an agreement. That type of agreement comes under the code. Then it runs on the Ethereum virtual machine, we mention it as EVM, and it also removes the intermediaries, which means we don't have any of the banking sectors. Example, the centralized systems. Next one, use cases of Ethereum, where use cases of Ethereum consist of decentralized finance, NFTs, supply chain, and then governments. And then decentralized finance, which means where nowadays currently we are using a centralized finance system, which means if I want to do a transaction, I want to access the banking systems. So they have to give the access and I have to log in everything, OTP, everything comes under centralized. Here decentralized finance, if suppose I am the user, I want to do a transaction to the end user, that I have to initiate and then he will receive the payment. There comes under the decentralized finance. And then NFTs, non-fungible tokens, it's a unique digital asset that are stored on the blockchain. Then supply chain, where supply chain comes under the transaction of transporting goods from one location to another location. Then governance, it comes under e-voting systems. Then next one, the challenges and the limitations, where challenge is the scalability, energy consumption, which comes under proof of work, high gas fees, and then transition to proof of stake. Where scalability initially means the storage purpose. If suppose I am storing a particular block and it has some type of storage capacity, but I can't have a large number of storage at a particular time. So these are the challenges. And then energy consumption, where energy comes under proof of work, where for proof of work we need a high computational power, which means for computing, which means for mining a particular block, I need high computational power. And then high gas fees, where high gas fees comes under, for a particular transaction I have to give some amount, which means some cryptocurrency to do a transaction. This is one of the challenges. And then transition to proof of stake. Here comes under proof of stake, which means two of the miners are going to do a mining process under the proof of stake concept. The miner 1 has a Bitcoin of 50 and then miner 2 has a Bitcoin of 10. The one who holds the highest stack goes for the mining process. Here comes under the challenges. Then the future of Ethereum, where Ethereum 2.0 comes under the merge concept and then proof of stake, consensus, sharding of scalability, and then more eco-friendly. Where Ethereum 2.0, which means it merges some of the smart contracts, combination of example proof of work and both proof of work and proof of stake. Then proof of stake consensus, where proof of stake consensus, which means a miner who holds the higher category go for the mining process, but it may overcome the process. Then sharding, where sharding is like splitting the blocks into separate parts and adding it to the some other block, which means for scalability purpose we are going for sharding. Then it is more eco-friendly to the peers that are going for transactions. Thank you.